is Ruth, and I did mechanical engineering at TMU. I don't have too many interesting things about myself, but I am very familiar with Ratatouille. It's one of my favorite movies, and I can recite, if not all, most of the script by heart. I really think that mechanical engineering was where I ended up because it allowed me to make the least amount of decisions possible in my initial early career days. So I wasn't sure what in specific I wanted to do for the rest of my life. And what I loved about mechanical is that you can go into solid mechanics. You can go into thermal or fluids or really whatever you want. You can do electromechanical as well or biomedical, and it's just there's so many different avenues that you could take it, and I was just so curious about the world around me, and it gave me a really good opportunity to learn and then sort of make those decisions as I learned more about myself. I also really like the fact that with mechanical you can choose a career path that allows you to do that very technical at the computer kind of workday, or you can also choose to have more of a hands-on in the field application sort of workday as well. So I like that you can have both one or the other, and it was really a lot of choice that you get. So that's what brought me to mechanical in specific, but honestly I think I would have been happy anywhere in the engineering discipline. I was really bad at math going into university. It was actually my lowest mark in high school, and for a while I didn't take physics at first in high school, and I took biology because I was so certain I wanted to become a pediatric specialist. And what really changed was I had physics one year in summer school, and I learned that you actually can't get by just memorizing things the way you can with biology. You need to really understand why things work the way they do and how they work. And I really loved that because turns out it wasn't necessarily that I was bad at math or bad at physics, and I learned this in university. It was that I'm not great at memorizing things just when they're put in front of me. I need to understand why they work the way that they do. And so the most challenging subjects for me in university were definitely the math related ones, the heavy calc ones. And I did not necessarily enjoy them until I learned what works best for me in terms of how I learn. Honestly, the later into my degree I went, the more I loved my courses and the more I loved the content I was learning. And I think it was because it became a lot less theoretical and a lot less generic or general, and it became a lot more specific to things that I could see an application for, and I can see sort of how it would be related into my day-to-day, and that really inspired me and strike this passion for me. So it's funny because you think that you need to be good at math and science to be able to do a certain job, but honestly it's all about the mindset that you approach problems with, and it's more about the skill set that you have. So things like problem solving, things like curiosity, attention to detail, those are all things that maybe people don't initially speak about when they try to consider a career in engineering, but they're heavily related into how well you can do in these subjects, but also how much fun you can have while you're in the discipline. I think in university everybody feels like it's either for you or it's not, a program's either for you or it's not, but I don't think that's actually the case. I went through waves where I felt like mechanical was for me and I'd be great at it, but also waves where I was mechanical feels like it's for me, but I don't know that I'll be great at it. And I think what it comes down to is just being willing to fail and then being willing to learn from those mistakes and pick yourself up and learn what did I do wrong, how could I have done it better. If you can figure out how you learn and what works for you, that's all that matters. It's not someone telling you to read the textbook beginning to end or take notes on absolutely everything, because maybe you just need to do a lot of problems, a lot of questions. So this is a bit of study advice, I guess, but just in general, the major piece of advice I'd give to a student struggling with their courses or even just nervous to head into the courses is just learn the way that you learn and then stick to it and learn what works for you. Don't be afraid to ask questions. You might feel dumb when you're asking them, but you'll feel so much better once you actually know the answer to those questions. And chances are there's somebody else in the room that has the exact same question as you, but is nervous to ask. I've definitely learned the hard way that there really is no such thing as a dumb question, and that the only way you can learn is by asking these questions and by being curious and allowing yourself to be curious, and getting rid of that self-talk that tells you not to be curious about certain things or tells you not to be the person that puts their hand up in class. Like it is okay, and it'll actually be better for you. So Mosaic Manufacturing designs, manufactures automated 3D printing solutions. So the mission is really to bring 3D printing and manufacturing to the factory floor. So what that means is that we have a really great future ahead of us where additive manufacturing is just beginning. And right now it's being used in a lot of smaller scale projects and hobbyists, things like that. But the potential to use 3D printing to really change the way that we manufacture is huge. Additive manufacturing has so much room to grow and to really revolutionize not only like sustainability, but also just the overall like efficiency of the way things are manufactured. So Mosaic works on building 3D printers as well as 3D printing solutions that sort of challenge that scalable vertical that the 3D printing industry is having right now, of how can we do this in a larger scale and faster, more efficient, more effective, that sort of thing. And within Mosaic, the specific project that I'm working on and the team that I'm working with is really tackling the textile vertical. So it's amazing that 3D printing you can print what feels like anything, whether it's like wood filament, metal filament, plastics. You can even print things that look and feel like adhesives or look and feel like fabric. So here's sort of some samples of different things that were 3D printed, and as you can see, like they quite literally feel like fabric. And I think that's really cool because this is something that we don't see very much right now, but I think there's a really strong future for it. So on the team I'm working on, it's more of like an application engineer, mechanical engineer side of things, where we're working on tackling the textile vertical. So how can we make this something that's possible in a scalable way? This specific industry as a whole, like I guess like looking at the broader scale, I'm really interested in additive manufacturing just as a sustainable solution to manufacturing. I had sort of like a moral dilemma of when I was like contemplating engineering and manufacturing, because I don't like the idea of just like producing stuff, like just more of things. But I do like the idea of producing it in a way that's as eco-aware or like as sustainability aware as possible, I guess, or just making those steps towards that. So for me, with additive manufacturing, sustainability was a huge component to it. But then ultimately it also like was the idea that I can work on something that can really change the way that things are done in the world right now, and really revolutionize the way that we think about manufacturing and we think about the products that we're creating. I think there's a lot of room for engineers to sort of consider the impact of the products that they're creating and consider sort of how these products are being like cycled through their entire life. And so Mosaic does a really good job of really looking at that and working on that in that area. So that's something that really drew me to the company, that along with just the really cool work that they're doing here. I think like the transition has been better than I imagined. Like when you're in school, a lot of the courses feel a little shaky, like you're not sure if you love them all, so it makes you wonder, like, I'm not sure if I'll love working as an engineer. The really cool thing about mechanical is that you can move around and you can try so many different things out. So I've had jobs that like have heavily used courses that I might not have loved in class, but ended up loving when I was using them in application, whether that was, machine design or vibrations, things like that, control systems, stuff that I had initially, like, when you're learning about it in an abstract way, you don't necessarily get to experience the application of it. And then when you do get to experience the application, it's so much cooler than I even would have imagined or expected it to be. So the transition has been great. It's been amazing getting to take what I know and apply it, but also just like continue to learn in those areas. It's really weird because like in school, there's a right or wrong answer, right? It's like you either like you have the answer or you don't have the answer. So it is like a really like strong mindset to break, I guess, the concept of like right or wrong. It's definitely something that was cultivated through like extracurriculars. So when I was on technical teams, like every year we would be building the same thing, like a car, right? Whether it's like the outboard system of a car. But then every year something changes, and that's just a testament to the fact that like the more you know, the more your ideas can grow, and like based off of what you're building off of versus like new constraints, like so much can change in the way something's done. But also on the non-technical side of things, like when we were looking at some of the problems that we saw in the world, like everybody had a different opinion on how things can be done or improved. And oftentimes there's also no right or wrong answer in those cases. It's just like a collective of different things that can work and can work together or maybe not. And so like if I only did school and didn't really explore the extracurriculars and the different like job opportunities, I might have graduated with the mindset that there is a right or wrong answer, and if you don't have the right answer, then you're wrong, which isn't the case at all. I don't think there's a right or wrong answer in a lot of like engineering problems, and if you don't have the right answer, then great. Like then you know that that's not going to work, and you know where you can head because it's anywhere but the way you've already tried so far. I'd say like my absolute top one thing I wish I did differently was just like be kinder to myself in the whole process. Completing any sort of university degree or like any sort of like continuous learning is extremely demanding, and it's very easy to get caught up in sort of like the fast-paced workflow of things and needing to like produce certain things, but I think it's important to take that time to like really think about yourself and your health, your mental well-being, and the people around you, and just like allow that to register to see what you need in the moment. Taking the time for yourself to check in makes you like better able to serve yourself as well as your team. So it's honestly doing you a favor in both ways by like taking a step back and not being afraid to do that. It'll be okay. Like I feel like engineering seems so stressful, and I feel like there's a huge like identity behind engineering and what it means to be an engineer. And I have not met anybody that fits that stereotypical identity. I've met so many more people who don't fit that stereotypical identity of an engineer. So like the sooner we let go of that and let go of the mindset that an engineer needs to be a certain way, the better off we'll be and the happier we'll be, honestly. I think like regardless of somebody's like any type of demographic, like you are where you're supposed to be, and you can be an engineer and be a really great engineer if you just allow yourself to be that. And I think it's also really important for us to understand. I know that there's like that saying that like engineers rule the world. We have it on our like leather jackets and all that, but we're really serving the world. Like we're really just doing whatever like people allow us to do and give us the opportunity to work on. So like I think once we understand like the importance of interdisciplinary work and valuing interdisciplinary opinions, I think we'll be set. We'll get really far and get to do really cool work. But first we gotta make sure we have like as many people on our team as possible. So.